Hello everyone. In this section we will discuss the linear regression model with TensorFlow. So here is the following given table of content. First we will discuss what is linear regression model, and after that we will discuss the implementation of linear regression model with TensorFlow. So now first we will discuss what is linear regression. Linear regression is machine learning algorithm that is based on supervised learning, and it performs a regression function. So the regression models a target is predicted value based on the independent variable. So it is mostly used to detect the relation between variables and forecast. And also linear regression is a linear model. For example, a model that assumes a linear relationship between an input variable and a single output variable. Linear regression is a statistical method that allows us to learn a function or relation from a set of continuous data. For example, we are given some data point of x and the corresponding, we need to know the relationship between them, which is called the hypothesis. So in the case of linear regression, the hypothesis is a straight line, that is hx equal to wx plus b, where w is a vector called weight and b is a scalar called bias. Weight and bias are called parameter of the model. So we need to estimate the value of w and b from the set of data such that the resultant hypothesis produces a least cost, which has been defined by cost function. We can also say that the cost function is also known as a mean squared error. Now we will learn about the steps that help in designing an algorithm for linear regression. So here is the example of linear regression model. For this we have started by importing the necessary libraries. We have used NumPy along with TensorFlow library for computation and matplot for plotting. So in order to make the random numbers predictable, we will define fixed seeds for both NumPy and TensorFlow by using np.random.seed function and tf.random.setSeed. So within this parameter I have set the value, that is 90. Now let us generate some random data for training the linear regression model. For this I am going to use the np.linspace function, which are available in the NumPy package module. Basically it is used to create an evenly spaced sequence in a specified interval. So the start value is 0 and end with 25. So basically we have to generate the 25 data points values, and the range value starts from 0 and end with the 25. So after that I am going to add noise to the random linear data by using np.random.uniform. Now I am going to tell about the how do we add noise in linear regression. So basically adding noise to the input features makes them less predictive of the response. So adding noise expands the size of the training data set, and each time a training sample is exposed to the model, and random noise is added to the input variables, making them different every time and it is exposed to the model. Now let us visualize the training data. For this I am going to use the plt.scatter, and within this parenthesis I have assigned the var1 and var2 variable. So now I am going to execute this code. Now we will start creating our model by defining the placeholders x and y, so that we can feed our training example x and y into the optimizer during the training process. For this I am going to use the tf.compat.v1.disable eager execution function, because in TensorFlow 2.0 version the tf.placeholder function has been changed, named as tf.compat.v1.placeholder. So within this parenthesis I am going to assign the float data type. Now we will declare two trainable TensorFlow variables for weight and bias, named as capital W and B, and initialize them randomly using np.random.randn function. Along with that I am going to assign the name, that is capital W and small b. Now we have defined the hyperparameters of the model by the new learning rate and the number of epochs, that is 1000, and the learning rate value we have assigned, that is 0.05. 1. So basically, learning rate allows the model to learn faster at the cost of arriving on a suboptimal final set of weights. Smaller learning rate may allow the model to learn a more optimal or even globally optimal set of weights. So that's why we have used the 0.01 value. And the epoch is used in machine learning to indicate the number of passes of the entire data set. Now we will be generating the hypothesis, the cost function and the optimizer. So for this we are going to use the gradient descent optimizer function manually, and it is built inside TensorFlow. After that we will initialize the variables. So as you can see that first we have calculated the mean square error, which is the cost function, by using tf.reduce underscore sum function. Basically, gradient descent optimizer is used to find out the values of coefficient parameters of a certain function, which reduces a cost function. And within this parenthesis, I have assigned the learning rate variable, minimize new cost function variable. So after that, I have initialized global variables by using tf.compat.v1.global variables underscore initializer function. Now we will begin the training process inside a TensorFlow session. So for this we are going to start the TensorFlow session with the name tf.compat.v1.session as session variable name. After that I have initialized the variables, that is session.run, and within this parenthesis I have initialized the global variable that represent in it. So after that I have iterate values through all the epochs by using for epoch in range, and within this parenthesis I have assigned the values new epochs. Now for feeding each data point into the optimizer, we are going to use the feed dictionaries within the session. So after that I am going to displaying the result after every 50 epoch. For this I am going to use the condition if epoch plus 1% 50 equals to 0. So now I am going to calculate the cost of every epoch. For this I am going to create a variable, that is c, and assign the new cost function and feed dictionary within the session variable. Now I am going to execute this code. So as you can see that the training process is now complete, and you can see that the model reached nearly minimum loss. Now let us look at the result. So in this case both the weight and bias are scalar values. This is because we have considered only one dependent variable in our training data. So if we have m dependent variables in our training data set, the weight will be an m dimensional vector while base will be a scalar. We will display our data. So as you can see at the output, the red line represents the fitted value, that is the value of y for each value of x. So you don't need to see the value of x to predict y. For each x there is any which belongs to the red line. You can also predict the values of x higher than 5. So if you want to extend the linear regression to more covariants, you can easily add more variables to the model. So with this we have completed the linear regression model with TensorFlow.